X. Okay, so till now, right, in this SAP 1, simple as possible computer system 1, right? In this, we have discussed how CPU fetches the instruction, right, by outing program counter, by PC out, PC increment, and reading the memory, right? And this is called as fetch cycle. Then how it executes the instruction after decoding the fetch instruction, right? And this is called execution cycle. Then also right, in we had only how many add, LDA, sub, out, and halt instruction. So LDA takes only 5T state, add and sub takes 6T state, while out takes only 4T state. And our fetch and execution cycle, right, both are of 3T state. So fetch plus execute cycle equal to 6T states. So while executing, say, LDA, 1T state is wasted, right? And during that time, 3E3 was the control word. 3E3 was the control word, right? During out, right, 2T state are wasted. So then, right, to avoid these not states, right? In fact, concept of variable machine cycle is there, right? Variable machine cycle is there, right? In that, in fact, whenever control word outage is 3E3, then this control word is decoded and fetching of the next instruction is started immediately, so that T state is not wasted, right? So variable machine cycle. Then at every T state, processor or controller sequencer actually outs a control word which is called micro instruction. Right? And these micro instructions can be generated using hardware control matrix. Now, if number of instructions are more, then designing of this hardware control matrix is not feasible, right? Not economical also, and it's a very tough job. So we go for control room, right? So in fact, in control room, these micro instructions are stored, right? And based on the instructions, once it is fetched, based on the instruction, micro instructions are generated by reading the control room. Of course, this control room, right, when micro instructions are generated using control room, then the system becomes slower. Why? Because this reading a ROM is a very, very slow process. कोणाला की? अच्छा अच्छा अच्छा, ठीक है. Right. So micro instruction as control room. Right. So control room is the solution for hardware control matrix when number of instructions are more, because hardware designing of hardware control matrix will become very, very complex. Right. If number of instruction increases, then we go for control room, and in control room very easily we can store the micro instructions. But of course, in that case, system will become a little bit slower. Why? Because taking out the micro instructions from a ROM, right? Because the ROM device is a little bit slower, right? And so it will be a little slower. So anyway, so these many things we need to understand, right, before moving to this microprocessor 8085, right? So let us discuss something with you. Ankita Kumari.
Yes, sir.
What do you mean by address state? Right. Of course, we discussed till now that SAFON system goes through different T states, right, in order to fetch and execute its program. So which T state is called address state? Ankita, why you have turned off your microphone? Ankesh Raj. Diksha Sinha. Deep Rishi. Why nobody is responding? I am recording this now. Activity. T states in order to fetch and execute its instructions, right? So which one is called address state? Quickly, Ankesh Raj. T1.
T1.
Yes. Next, Ankita Kumari. Yes, Ankita. Not listening. So
Yes, sir.
yes, Ankita. Why you are? Oh, sometimes you are turning off your microphone and turning on your microphone. See, just turn on your microphone